today Jiří Kvaček with his lecture about new gymnosperms and angiosperms from the Cenomanian. Jiří, please speak louder.
Okay, so I will start directly about on that the topics which is already introduced: new gymnosperms and angiosperms in Cenomanian Peruc Flora, Czechia, Central Europe. So first, I would like to start with late Cretaceous paleogeography. So Bohemian Massif was one of the islands emerging in shallow epicontinental sea, which was covering all Central and South Europe. And north of the island, the Bohemian Cretaceous basin was formed. So here we have a map of Czechia, and also in gray we have Cretaceous sediments. North of Prague, there is the Bohemian Cretaceous basin, which is basically filled by mostly marine sediments. Only in its basal part there is Peruc formation, which is formed by fluvial and tidal, shallow marine and offshore marine sediments. So prevailing is terrestrial sedimentation there. Here in the map there are several asterisks where there are 4 localities. The most important one is Pecinov, and the second important is Vyšořovice Horoušany. We have also material from Slany and Harcov. So Pecinov locality, it is the most complete section of the Peruc formation. My colleagues, sedimentologists David Uličný and Lenka Špičáková, studied this section using sequence stratigraphy. So they defined 5 units there. Yes. On the Paleozoic bedrock, which is formed by Carboniferous sandstones, here we have unit 1 and 2. They are formed by fluvial sedimentation of Braided River, mostly sandstone pedestals with small lenses, claystone. Then unit 3 is represented by sedimentation of subpertidal marsh, meaning mostly mudstones with abundant flora. Unit 4 is less it's quite smaller, doesn't usually contain plant remains. And unit 5, it's a product of sedimentation of estuary mouths, subtidal, supertidal environment, and offshore, particularly here in Pecinov, where we are already in marine conditions. So flora comes particularly from unit 1, 2, and 3, and 5. So Špičáková and Uličný were able to reconstruct the Bohemian Massif drainage system using 2 major sections in Pecinov and Horoušany, but also more than several hundred boreholes. So they were able to trace and 2 rivers, actually. The green color shows extent of paleo valleys of these rivers, which were draining the island to the north. But also some smaller trunks draining the island to south to the Tethyan Sea. Out of these sedimentary and palynology and plant macrofossil studies, we are able to reconstruct several major paleo environments. On this block diagram, we have braided river, and in brown color we have upland vegetation. So this visualization were done by our colleague Jan Sovák. Braided river is high energy environment, which is dominated by a lauroid plant, Eucalyptolaurus, earlier titled Myrtophyllum, this inflorescence Maudinia. This plant was shrubby, similar to its physiognomy to modern willows, and was able to grow in this high energy oligotrophic environment. More stable parts of the alluvial plain were formed by platanoids and other plants. Upland vegetation was probably formed by fern prairies. We have plenty of small charcoalified parts of ferns, but also solitary conifers, benetites, and angiosperms. More about environments. Meandering river. Here is its reconstruction dominated by lauroids Myrtophyllum and platanoids Insaucenia. It's, as you can see, it's low energy environment with very rich, nutrient-rich substrates, which probably generated high diversity of plants, particularly angiosperms. And another important paleo environment, salt marsh. Salt marshes grew probably, or we quite sure, in supertidal position, so not directly in tidal, but supertidal position. They were dominated by a conifer Phrenolopsis and Kinkophyte plant with leaves, Ethmophilum, and reproductive structures, Nehelidiella. So let's have a look in some fossil plants. First, we have a cycad, Nilsonia nirvanae. It comes from Petzinov quarry from Unit 1. It's quite fragmentary. Here we have actually a fragment of pinnate leaf. So its stomata are hypohalic, oriented parallel to the leaf margin, forming dents. Stomata are sunken in pits and surrounded by subsidiary cells with quite well pronounced papillae. The ordinary cells show ridges. So fragmentary character of this plant and also its micromorphology clearly indicate this plant was probably part of upland vegetation. We are coming to benetites. This Zamipes pateri, which I devoted to my father, comes also from Petzinov from Unit 1, and in macromorphology does not much differ from Nilsonia, showed earlier. But if we macerate a cuticle, that it's clear that it's a benetite. Clearly, you can observe these sinusoid anticular walls, syndatohalic stomata, which are oriented perpendicularly to the leaf margin. Stomata are again sunken in pits and surrounded by papillae, which are also covering all other ordinary cells. So also this plant we interpret as a part of upland vegetation. there is another venetide, Psychedoidea, which is also from Pecínov, but in this case, unit 5. Sorry, I just need to make it like that. So this plant comes from unit 5, and it is already marine sandstone, and it's clear that it's allochthonous there, and because of its physiognomy and other indications, so we also consider this plant as a part of upland vegetation. It shows very nice leaf bases forming hermit surface or stem, which is quite useful against frequent fires, which we know took place there, and also reproductive structures are embedded among the leaf bases. This plant needs to be studied in more detail, so it's my task for future. Damarites albens, we are coming to conifers, also from Pecínov unit 5, also again allochthonous, but we have Damarites in situ preserved in unit 3, so we are quite sure that this plant comes from this salt marsh vegetation. This silicified cone is quite unique specimen. When cut, it shows quite large seeds. We studied this plant with neutron tomography. Here, because silicified material, it was quite difficult for X-ray, so we tried neutrons. It's just the investigation is just in process. So the cone shows helically arranged large seeds. There's one per unit, and it's always subtended by a sort of leaf or similar or bract. So that's the Damarites. Now coming to Cupressaceae. This is Stutzella strobus bohemicus from the locality of Harcov. It's all we have in the material. We have oleferous cones attached to twigs or sterile twigs. Oleferous cones are about 5 centimeters large, consisting of about 60 helically arranged bract scale complexes. Each bract scale complex is simple, flat, thin, delicately ribbed, showing dentate margin. It's bearing 2 and 3 or 3 winged seeds. Systematics of this conifer is clearly coming from, or we can assign this conifer to basal families Cunninghamioideae or Taganoideae. Sterile twigs of this conifer are of brachyphyllum type. Leaves are antistomatics, antistomatic adaxial cuticle bearing 2 bands of monocyclic to anticyclic stomata. Nice stoma is indicated here in the center. So here we think of this plant was probably coming from alluvial plain vegetation because it is associated also with use of Eucalyptohaurus. Now I'm coming to angiosperms. Pseudastrophylates Pitaceus. It's a enigmatic plant, and for a long time it was not clear if it is really angiosperm. This we were able to clearly show because of the clearly angiospermous anthers associated and now found also attached to twigs. So we have leafy twigs, we have also a male and female flowers. These are very simple, decussately arranged here, seemingly whorled, but these whorls are actually formed by short branches. So these twigs are formed by sort of short shoots. Female flowers are unicarpellate. It is shown here, or singly in axial of bracts here. Those bracts are also preserved in basal parts of this specimen, which is we have got from bulk maceration. Details like slit-like stigmas are preserved here, and also complete seeds are quite common there. They are ribbed and indehiscent. Seeds are pendant autotropous. Here is a, and also here we can see the hilum, which is obliquely oriented. So this plant we described in cooperation with Jim Doyle and others, and it is, in our understanding, it represents a link between Corantaceae and Ceratophyllaceae. I will show you more details about this plant. I don't know if I mentioned that. It comes also from Petzinov, but from Unit 3. So Unit 3 is salt marsh. So this plant is halophytic, which it is quite clear. It shows also the morphology of sterile leaves. Now we have male flowers, which are arranged in spicate inflorescences, consisting of 1 to 5 flowers. This is quite nicely preserved flower consisting of 1, 2, 3, 4, 5 flower. It's an inflorescence consisting of 5 flowers. Here we have well preserved inflorescence consisting of 2 flowers. Here we have here is a bract, and here we have that quite massive filament of first flower, and this is a second flower. Here we have its filament, and here complete anther. Here the anther is the pollen, so it's absent here. It's clearly not complete inflorescence. So anthers are frequently found isolated. They are ovoid, elongate, massive, possessing an expanded connective, which shows even stomata. So they were probably photosynthetic. The extension is quite nicely shown here. And anthers are tetrasporangiate, consisting of each theca consists of 2 narrow pollen sacs. In this anther, we can see even all 4 pollen sacs very well in this translucent unique specimen. Pollen is tucanopolis, and there are some details which are done in actually by Maria Tekleva. Thank you, Maria, for this. Tucanopolis is a monosulcate with quite broad and short aperture, microgranulate subtectile sculpture is seen in here and here. Infractextum is consisting of columella and granules, or here quite homogeneous foot layer and much thinner structureless endexine, which is in aperture part is quite expanded here. And also in this aperture part is nicely shown finely laminate endexine. So as I mentioned, this plant is clearly a herb from salt marsh. I'm coming to angiosperm foliage. This one is quite old specimen from the time of Velenovsky, when he named this plant as Aralia saportanea. But after publication of Todziaphyllum by Louis Sender et al. In 2021, we decided to transfer that from Aralia to Todziaphyllum because of numerous similarities. It's also found in Horoshany and Slaný localities, showing serrate leaves, this leathery surface, and colorantoid teeth. They are clearly shown here, and here we have, for example, one nicely preserved, and reticulate tertiaries. Quite a rare occurrence of this foliage, and also in consideration of the other leaves which will come, we consider this plant also probably growing on upland. Now I'm coming to Ascarinophyllum pecinovense. Ascarinophyllum we introduced and designed by my colleague Jana Čepičková and me in 2022. We were inspired by Ascarina rubricaulis, growing now occurring in New Caledonia. The leaf is shown here. It shows a number of similarities to this plant, so we decided to make the name Ascarinophyllum. It comes from Petsinov units 2 and 3. It has quite serrate, leathery leaves, and very variety of stomata, like we were able to detect. Here we have some brachyparasitic stoma, here laterocytic, and here stephanocytic bicyclic. So there are two cycles of ordinary cells. There are also characteristic T-shaped thickenings in stomatal poles. I will talk a little bit more about this Ascarinophyllum. Venation was quite difficult to detect because of the leathery nature of foliage. So we made a leaf transfer and carefully macerated the leaf to get some bleaching and some more translucent image, which is here, and we try to make some basic venation, but it was quite difficult. But we concluded that it's very probably a semi-craspedodromous venation pattern. And here we have a variety of stomata and resin bodies, which are quite important. Here we have the resin bodies in a nicer view under number 3. Another aspect is pronounced striation of these of the axial cuticle. The striation is sometimes radial around stomata, sometimes completely without any particular direction. So this plant was found only in one place near to the slope of the river system. So why we are prone to also this one interpret as a plant of upland slope. And so the final plant is Papillephyllum labute. It's another new genus which is based on its cuticle characteristic feature. Its abaxial cuticle is completely covered by papillae, which is an interesting and important character. On the other hand, it complicated our studies because using light microscopy, it was quite difficult to detect stomata and other characters over all of these large papillae. So the dentate leaf, which is shown here, it's the holotype. There are those characteristic papillae, and it's quite nicely shown chlorantoid teeth, but this is maybe better seen in these fragments. These fragments are gained through bulk maceration, and we have, let's say, about 100 of variously preserved completely dark fragments of this foliage, and only these 5 are actually naturally translucent, and it is very useful for us because we were able to detect the semicruspididermal venation here and a nicely preserved chlorantoid teeth. So that papillae in the chlorantoid teeth are quite nicely seen in this image from fluorescence microscope. As you can see here, papillae surround stomata. Usually it comes like that. So in light microscopy, we do not see much. So that's why we were looking for better inner side in the inner side of the abaxial cuticle. We were in some places able to trace some of these stomata, which are stephanocytic, bicyclic, or lateral cyclocytic. So this is our last leaf. Concluding, so Peruc flora is quite large, consists of more than 254 taxa. 9 of them were introduced in this presentation: cycad, benetites, conifers, angiosperms. 5 of these showed mesophytic, xerophytic characters, indicating an upland vegetation origin. So in this diagram, we also can observe percentage. So in the pale blue, we have angiosperms. Sperms are in dark blue, and gymnosperms, including conifers, are here. So clearly, Peruc flora is one of the first Cretaceous floras, leaf floras, showing the change of prevalence from gymnosperms to angiosperms. Angiosperms prevail, occupying nutrient-rich alluvial environments. Gymnosperms show clear decline, occupying less favorable environments like dry uplands and marshes. Oh, thank you for attention. And this is from Prague.
Thank you, Jiří, for the interesting talk. Anybody who wants to pose questions may raise a hand or write the question in the chat if you prefer.
Chat.
I see a hand, and switch on your phones if you want to pose the question.
Mario?
Do you see?
I see Mario, yes, but he is not, your microphone is switched off.
Could you switch on your microphone and then ask your question? Yeah?
Okay, it's okay. Can you hear me?
Yeah, now.
Okay, congratulations, Jiří, for your nice talk about the Peruc Flora. I would like to ask you something. You say in your last slides that the Peruc Flora is the first flora from the Cretaceous in which the angiosperm prevail.
Yeah, I was saying
gymnosperms, yes?
among the first. No,
yes.
I didn't say the first.
Yes. But here in Portugal, as you know, we have and Peruc Flora, if I understand, belong to the Cenomanian, yes?
Yes.
Yes. We have here in Portugal, as you know, the Petrifica Flora from the Apsian Albion. So it's an older flora from the early Cretaceous. And here in the Mesofossil Flora, as you know, we have the same situation, at least in the Mesofossil studies, we have angiosperm prevailing on gymnosperms too.
Yes.
And I would like
that's why I mentioned that it is the leaf flora and one of the first. Because I have this understanding that Mesoflora in Catefica shows clearly prevalence of angiosperms already in Albion.
But my question...
that's why I was quite careful in putting wording in my conclusions. So
okay. And what about in what happened with the Palinoflora? Because in Catefica we have the contrary situation. In the Palinofloras we have the gymnosperms dominate, and the angiosperms are subordinate under the Palinoflora. You have the same situation in Peruc or not?
No. There are two things. First, we have quite clear. I want to ask you if it is in terms of abundance or in terms of diversity of taxa.
The diversity and numbers.
Okay, both.
Both, yes.
Yeah. In our case, it depends where we are. If we are in salt marsh, we have clearly prevalence of Classopolis and Phrenolopsis, so this is clear. If we are, I did not mention swampy vegetation. We have cupressoid conifers there and also prevailing. But in river sediments, we have angiosperms prevailing. So it depends where we are, in which environment. And in my understanding, angiosperms occupy really those the nutrient-rich environment which were quite sort of the best environments for plants.
Okay, I understand.
So particularly those from within meandering rivers, we have really prevalence of angiosperms. So this is first, and the second, we do not have completely lack or lauroids are completely lacking in Palino spectrum, and here particularly in Cenomanian lauroids are really one of the major components of the flora. So even without lauroids we have prevalence, but we really lack quite a lot from the diversity in palynology in Cenomanian.
Okay, Jiří, thank you.
Thank you, Mario. Alexei.
Yeah, thank you. Jiří, thank you for your very interesting talk and very useful introduction to this famous and very rich flora. Saying about Peruc flora, are there any other less rich but similar floras, similar to the Peruc flora in Central Europe? or this is just unique?
No, I mean that we have, in terms of Cenomanian, it's unique. Actually, not Mario. Seeing Mario, I cannot say completely unique because in Portugal there are quite interesting Cenomanian floras as well. So, but in terms of diversity, I think it's quite unique within Europe. There are Coniesian. Together we worked on Campanian flora in Grünbach. So these late Cretaceous floras are more common, but usually preservation is not so excellent, and but they are. But Cenomanian is flora of the Cenomanian is probably the best in Central Europe, perhaps in Europe. It's also in terms of preservation and also in terms of preserved paleo environments. In France, we have Cenomanian, but usually we have quite narrow taphonomy windows. Here in Pecino particularly, we have we can read the environment step by step, seeing differences in different paleo environments quite clearly. So this is quite unique, I mean.
Thank you. Jiří, for my experience in northeastern Russian floras, the very first angiosperm-rich floras started from latest Albion. Do you think, might it be that Peruc's flora is latest Albion and younger, or you are sure that it's Cenomanian, or maybe there are more latest Albion floras in Central Europe, maybe not very rich, but still with plenty of angiosperms.
Some of the really some plants from deep boreholes of east of the Bohemian Massif, they are thought could be Albion, but most of the flora is based on first occurrence of Normapoles, and it's clearly mid-Cenomanian. I mean, it's unfortunate. There are Albion floras in Iberian Peninsula and perhaps also some French localities where angiosperms are also frequent, and that's why I was quite careful in wording, saying that it is one of the first. It is not definitely the first, as mentioned by Mario. So, but also we have good leaves, good foliage here, so we are able to understand a little bit more the angiosperm connection between fruits, fructifications and leaves. But I'm sure that there are some good Albion floras in Spain and Portugal, but I'm partly familiar with them, but in none of them I have seen, except Catefica, I have seen such a, in terms of angiosperms, I haven't seen such a diversity, yet. But I'm far off that saying that that Cenomanian, our Cenomanian flora is first showing the prevalent. I mean that it started in elite like Albion, and you are right.
Yeah.
We do not have enough good floras in this moment to show it to this picture.
Thank you. Think about a very good flora, Peruc's flora. I think European paleobotanists started to study this flora 200 years ago, about 200 or even more than 200 years ago.
It was. I mean that first plants were already described by Kaspar Sternberg in 1820, actually, but Velenovský and Korda Korda in 1846 and Venos in 1882. They started describing this flora. So the flora is very old and well known, particularly from Vyšehořovice locality.
Yeah, and at the moment you have almost 300 species in this flora. Are you still able to find new taxa? Or how often can you find new taxa and just sure that it's a new one?
It's I can say this way, because we are now using bulk maceration, so we can see really small details, small flowers, small fruits and seeds, much more than were described by Knobloch. He focused on seeds and fruits and megaspores. So in this area, there are quite a number of new and undescribed taxa. We already see, I don't know, we have quite a lot of bulk macerated material, but I have no time to describe it. But gradually it will come, and there is my major target of undescribed taxa. Macrofossils, very rarely. Sometimes when we can study cuticle, then we can say, because here it's really difficult without cuticle, as I showed Nilsonia and Beneta, Zamites, they are quite similar in physiognomy, particularly if we have only fragments of fronds. So we need cuticle analysis. So I have one genus Dioonites, where I usually assign these impression materials, but we cannot say what it is actually. It could be a venetide, it could be a cycad. So these new taxa sometimes are generated by cuticle analysis, because then we are able to say something more with some more higher degree of certainty what it actually is. So it happens that even there we have some new taxa, but rarely.
Yeah, thank you, Jiří.
Thank you. Meantime, we have questions in the chat.
I see.
Natalia Nosova asking you, are any vines visible in the Nilsonia leaves? As a rule, a cuticle of the Nilsonia leaves is very thin. You show enough thick cuticle. It's very uncommon for Nilsonia stomata.
Yes,
please comment.
Yeah, I mean that this fact I know, and we have more species of Nilsonia here, so these are having quite thin cuticle. This is completely right, and actually it was like martyrium. It was really difficult for us to determine what this plant is, and we were advised by Johanna van Konienberg van Sittert. She told me that she advised me that she saw similar plant which she assigned to Nilsonia, and so I was really puzzled there, and so I followed this advice, and yes, I agree, this is strange. This is a strange Nilsonia, and perhaps we can say something more. Johanna,
Yeah, Han, could you show also? We can hear you, but we do not see you.
Yeah, well, that's not in.
Microphone.
But microphone. Could you switch on the microphone?
Yep.
Oh, now both
it's
are
all
working.
on. Yes, we have a similar Nilsonia species from the Cambrian late Jurassic flora from Scotland, from Sutherland. And we were also baffled by it, because indeed, normally Nilsonia species have very thin, difficult to prepare cuticle.
Yeah.
And these are easy, thick, and they are very similar to what Jiří showed from Peruc Flora. But it has all the other characters of Nelsonia. So it must have been some adaptation to environmental circumstances, I think. And that is the only thing I can think of. But Natalia or Jiří, if you know anything more, tell me, please.
No, I do not have more. And I'm very happy, actually, that we were able to identify that plant. And also, it makes sense that this small fragment is actually really some plant which was growing in sort of in higher, maybe even in mesoxerophytic sort of conditions, because it's a small fragment of plant with exactly in the river, in a small river, which probably was able to collect this material from upland. So for me, it makes sense.
Yeah, our material is also very probably coming from more upland flora. So I agree there.
Natalia?
What about venation? Is it visible in any vines?
There's parallel venation, nothing more. We have a fragment.
And
the
same in Scotland, parallel venation, clearly Nelsonia type venation.
Do I share my screen still?
Yes, there you are.
Maybe I can. Yeah.
Yes.
So parallel venation. Yeah.
Yeah.
What is Natalia? What is your opinion? You have some other interpretation?
And how many stomatal bands here? 2?
Oh no, many. Each of these, each of the vein has its, you know how it is. Intercostal and intercostal bands are interchanging. So there are many. I don't know how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, more than 10, 15 perhaps. So what do you have some particular idea?
The stomata some similar to Tritania or maybe Mirovia, to conifers.
Oh,
No.
I don't know.
Yeah, actually, for Scotland, we have a lot of Tritania material there.
Yeah.
But it's different, and the whole appearance of the leaves are different. I can't see on the moment. I can't see anything else than Nelsonia, but maybe we could come up with something new.
Yeah, I mean, I'm open to any. We do not have a compound leaf in this case, so why not? It could be. Yeah.
Yeah, but normally Tritania has only a few stomatal bands, and
yes, this is right.
And here we have many veins, and in between the vein, in between every pair of veins, we have stomata.
And do you have any photos from inside in SEM, in scanning microscope? Only outside, yes? Not?
Yeah, I have it inside as well. It's published. It is in fossil imprint, so it is published. We have it. So do you think that? We can talk about it later. It's interesting, actually, idea. Yeah. But in this moment I have it. I'm happy that I have something which is again sort of showing as a sort of relict of lower Cretaceous and Jurassic for us in our Cenomanian ones.
Yeah.
Both Tritania and Nelsonia are of the same kind.
Will be a nice discussion. We have even published the material from Scotland, also some pictures from the inside. So,
thank you.
Thank you.
One more question from the chat from Tatiana, I suppose Faraponova. Thanks for the talk. How did you reconstruct the paleo-environments and identify the dominant plants? Maybe you could share any articles in which you write about it.
Yes, we have done, actually, I have one paper with Ulichny in 1997, and now I'm preparing a new paper on it. It should be finished by the end of this year. We have several methods how to estimate. First, quantitative methods. Quantitatively, which leaf or plant is prevailing. Usually it is probably the dominant plant, like in terms of Phrenolopsis. It dominates Phalanospectra and also macrofossils. So this is very clear. In the Braided River, we have, I haven't showed, but I didn't focus on that, but we have bulk macerations that plant which we now term Eucalyptolaurus, earlier Mertophyllum, and biome structures of Moundinia. So here we are very, very confident about quantity. About paleo environment, we use that paper is now in press. It's another student of mine working on geochemistry using carbon isotopes. So we use carbon isotopes for recognizing plants which had sort of water stress, because there are two isotopes, 12 and 13, and the lighter one is more suitable for photosynthesis. So if plants are okay growing in wet conditions, they have open stomata, so they consume first the isotope 12, and the 13 one, isotope 13 is consumed only in the case when the plant is closing the stomata because it is water stressed. Because for some reason there is not enough water and plant is closing its stomata. And in that case, carbon isotope 13 is consumed by the plant, and it builds it in its molecules, and it is seen even in analyzing cuticle that this plant was water stressed. So we have this sort of indication for plants which were water stressed and which were growing in fresh water. Certainly those plants which were growing in brackish water are also water stressed. But we have another indicators like sedimentology, tidalids, and other complete reconstructions of shoreline. So we had also presence of marine algae and other in Phalanospectra. So we have additional sort of, it's a combination of several approaches which can give us this understanding of and for reconstructions of these environments. So
thank you. And a question somewhat related from Arun Joshi, also in the chat. Congratulations for such a wonderful talk. How does stomatal index help to differentiate amongst different species of a particular group, angiosperms or gymnosperms? And can we make morphotypes rather than different species for the fossils?
Yeah, that's a very complex question.
Yeah.
We use stomatal index is rather more suitable for CO2 concentrations. So we do not work so much with this with stomatal index because it differs from plant to plant. So in this moment we do not have we are not focused in that way. Why we are not using morphotypes? I think that we are in fossil plants, we are always sort of using morphotypes. Even if we know a little bit about systematics, these plants are actually, we cannot say. In terms of, for example, those lauroid leaves, we are quite sure they are very similar to each other, and some of them are associated with different reproductive structures, also even sometimes attached. So in that way, we know that one leaf morphotype can be associated with more than one reproductive structure. So this is clear. But in some cases, like some conifers, which occur in really high quantities, even association and cuticle similarity can give us some clue to understand how these plants, what are the reproductive structures of some frequently found twigs or so. So how the whole plant concept could be applied to some of those. Not always, not to all of them. It's difficult, yeah. But we are it's a sort of detective story, and we are still having new discoveries, new finds, and new proofs. So yeah, that's life.
Thank you. Meantime, Tatiana writes you thanks in the chat, and edit that using of carbon isotopes is really interesting.
Mm-hmm.
And now a question from Evgeny.
Mm-hmm. Thank you for its interesting talk. My question is about T-shape thinking on stomata.
Sorry, T-shape.
T-shape thinking.
Yeah.
How I not understand how to recognize it. Can you show a slide with it?
Yes. I
the first time
do not know if this is the best slide.
This.
Yeah. It's. Oops. Here we have some of these are, for example, here and here. Some of them are here. It's not clear here. Yeah, not here. We have it. These T-shaped thickenings are not present in all of the stomata, but quite common.
Yes, thank you. I understand.
Arun Joshi writes you thank you very much for the answer. And Bruce Cornett writes not a question, but a link to a paper related to Cenomanian flora from the United States.
Oh, yeah.
Well, I do not see more raised hands, so may I ask my own question?
Yes.
Well, you have shown Damaritis, Stutzlitza strobus, strobius of gymnosperms, but I did not understand which group of gymnosperms they belong.
Yeah, it's a good question because I do not know. I mean that with with Stutzelia strobus, it's quite clear to me. It should be cupressoid because there are two to 3 seeds. I can show it. Just sorry, I was just working on that. Where is it? Here, yes. So the cone is, so there is clearly helical arrangement. These bract scale complexes are always having more than 2 seeds, so we cannot say this is Pinaceae. And then there are not so many other groups we can associate. And I did not include all of my images, but some of them show clearly the wing of the seed and also the shape of the seed, which is quite similar to Cupressaceae. So in my understanding, if there are only 2 seeds, it could be also Taiwania. But Conninghamia has more seeds per complex. So it's somewhere in between these 2 basal subfamilies of Cupressaceae. So it's my understanding of this. And also its cuticle is and shape of the leaf. And so in my understanding, it is Cupressaceae.
And do you have a suitable pollen type in the pollinological assemblages?
Yeah, there's plenty of Cupressaceae in our Cenomanian. So and it would be nice to have a pollen cone, but it's difficult. Yeah, but here with Damarites we have more problems, and it was originally described as a conifer. Later, it was interpreted by Hruštík as a kind of unknown gymnosperm, and I followed these interpretations until I found this cone. So here are clearly shown seeds, and certainly I would love to talk to Sergei Naugolny, who is working with, because this plant is very enigmatic. It has very, I did not bring these images, but it has very long cordite-like leaves. And one of the ideas is that it could be even associated with this strange with this group, but I'm far from conclusion, and I cannot say more. If you have any interesting interpretation, I would love to hear that.
Thank you. Well, do we have more questions to our speaker? It seems that we don't. Well, if so, thank you very much for... Oh, Han want to ask something. Han, please switch on the microphone.
I have.
Yeah.
I want to discuss later with you, Jiří, because I have to leave now for another appointment. But this cone of Damarites reminds me also of a Bernetia that we find in the Liassic. Somehow it has similarities and the same type of leaves. So, and there it's considered to be gnetales or whatever. So it is, for me, it is just something I would love to discuss with you later privately. It's a very strange, interesting cone.
Yeah.
It reminds of Araucariaceae, but
yeah, in some way, yeah.
In some way, yes. In other ways, no.
Yeah, that's right.
Okay, well, sorry, I have to leave, so.
Okay, fine.
Thank you.
Okay, bye. Thanks,
Bye.
Jiří.
Well, we have 2 more thanks in the chat, and it's the last occasion to pose question. Well, okay, thank you for the talk, thank you for the discussion and for coming to us, and thank you to all your listeners for coming and join us.
Yeah, thanks for listening. Yeah.